Now I am going to talk about Adams-Bashforth method. The Adams-Bashforth method is given by the formula for the second order method. So that is called Adams-Bashforth 2. Remember the formula. Yn plus 1 is equal to yn plus h by 2. 3f xn yn minus f xn minus 1 yn minus 1. And for third order method Adams-Bashforth 3, yn plus 1 is equal to yn plus h by 12. 23f xn yn minus 16f x minus xn minus 1 yn minus 1 plus 5f xn minus 2 yn minus 2. So remember this formula. So after doing the derivation we will get that 23, 16 and 5. Okay, so remember this formula. So second order method and second order method and third order method. Now again we can take that example. Dy by dx is equal to x square plus y with at x is equal to 0 is equal to y is equal to 1. Now using Adams-Bashforth method we can approximate the solution of this ODE. Now here we are taking that x is equal to 0.2, that is not 0.2, actually 0.1, with step size is equal to 0.1, means at y is equal to y1 at x0 is equal to 0. Now Adams-Bashforth that second order, so f of x0 y0, so that is 0 square plus 1 is equal to 1, means we know that f of x y is actually x square y. So from that we can calculate that 0 square plus 1 is equal to 1. Now we can use that Adams-Bashforth second order method. So y1 equal to y0 0.1 by 2 into 3 into f of x0 y0 minus f of x minus 1 y minus 1. So that is actually 0. We don't have no value of x minus 1 and y minus 1 value. So that is 0. So 1 plus 0.1 2 by 3 into 1. So that will give 1.15. So Adams-Bashforth second order method y1 will be 1.15. Now Adams-Bashforth third order method. So now we are already getting that x1 is equal to 0.1, y1 we also get 1.15. So f of x1 y1, so that is we know the f of x y is equal to x square y, means dy by dx is equal to x square plus y. So that is f x y is equal to x square y. So x1 we know, y1 we know, that is 0.1 square plus 1.15. So that will give 1.115. Now y2, so y1, that is Adams-Bashforth third order method, y1 plus 0.1 then by 12, means h by 12, 23 f of x1 y1 minus 16 f of x0 y0 plus 5 f of x minus 1 y minus 1. So that will directly 0. Okay, and then we have f of x0 y0, so that is we got 1, so that is 1, that is 16, and 23 into f of x1 y1 1.115. Now after plugging all this value and that doing the calculation we can get that 1.25542. Now step size y is equal to 1, so that is y 0.1 is 1.15 for the second order method, and y of 0.2 third order method is 1.25542. Check the calculation. That's it about Adams-Bashforth method. Now I am going to talk about Milne Predictor Corrector method. Milne Predictor Corrector method. So ypn plus 1, so that is predictor step, yn minus 1, that 4h by 3 2f xn plus xn yn minus f of xn minus 1 yn minus 1, and corrector step yn plus 1 yn plus h by 3 f xn plus 1 ypn plus 1 plus 4f xn yn and plus f xn minus 1 y minus 1. So that is corrector step. Okay, now again we are taking the same example. So dy by dx is equal to x square plus y, and y at x is equal to 0, that is 1, and we have to calculate the approximate solution of the ODE. Okay, now first we are going to calculate that predictor. We are using predictor method. We are calculating predictor y to p. So y to p we know here. So if we take that n is equal to 1, so that y to p is equal to, so if n is equal to 1, y to p is equal to y 0 plus 4h by 3, then 2f x1 y1 minus f of x0 y0, that we will get. So now we are doing that calculation here. So now y to p is equal to y0 4h by 3 f of x1 y1 minus f of x0 y0. So f of x0 and y0, 0 square plus 1, so that is 1. F of x1 y1, so f of x1 y1, so we can do that. Y1 we can calculate by Euler method, y0 plus h into f of x0 y0, so that is 1.1. so f of x1 y1, so that will get 1.1. so we know all this value. If we plug all this value, so y to p predicted y2, that will give 1.168. we plug all this value, we can calculate that. Now y2 corrector step. So here that corrector step, now again n is equal to 1 means y2 is equal to y1 plus h by 3 f of x, that is 2, and y2p, that will get from here, plus 4f x1 y1 plus f of x0 y0, that will get. So that equation will get here. So y by 2 y1, h by 3 is h is equal to 0.1, f of x2 y2p, 4f x1 y1, f of x0 y0. so f of x0 we know already. So now f of x2 y2p, so that is 0.2 square plus, again, so we know dy by dx is equal to x square plus y, so that is f of xy. Now here we are plugging x2 and y2 yp, so that is x2 is 0.2 square plus 1.168 yp, so that will give that function value is 1.18736. now y2 will be y1, we already got 1.1 plus 0.1, everything if you put and then if you calculate, ultimately y2 will be 1.16144. so now predictor corrector method approximate at x is equal to 0.2 with a step size 0.1, y at 0.2 will get 1.16144. that is the answer. That is about Milne predictor corrector method. If you have any question, you can email me and subscribe my channel. That's it. Thank you.